Hello friends, today we are going to see the structures topic. When we want to create the custom data type, uh, then we require to define it or declare a structure. A structure combines one or more variables into the single type. You can define the functionality by adding the type and instance method to the structure. So here we are going to see the how to create the custom structure, and then how to define the properties on a structure, and how to add the methods or the functions to the structure. Now for the defining the structure, we are using the keyword struct keyword, then the name of the structure. So here we have given the name of the structure as a person structure, and then inside the braces you can see one variable called as a name we have defined with the data type as a string. You can capitalize the type names, and you can use the lower cases for the property names. So this is how regarding how to define the structure if you when we are creating in Swift language. Then how to assign the property values to the person. Okay, so here we have assigned one property name called as a name to the struct person having the data type as a string. But when we want to call this structure, you have to create the instance of that structure. So here we have created the tangible instance, that is a person of the person structure. Okay, so you can see we have created the person constant, and then let person is equal to person, which is called to the struct, and inside the braces we'll have the name Jasmine. When we are to print that, you have to go for the object name instance name dot property value. So we will see how this will look into the playground, or how it will be executed into the playground. I will go to the Xcode. Open the playground. Give the blank, take a blank playground. Give the name as the structures. Create. So we have created the struct person here with the property, one property, that is name. Now we are going to create here one instance of this structure, struct let person equal to person, and when we write the person here, and then you can see by default the Swift will have the guide Swift will guide you for your the how what the properties are present inside the struct person. So you can see here you can have the name property here, so we will choose that name, and string value I will put here as a I will put the my name here, and how to call it. We have for the calling I have to first write down the object name person is the object dot, then you can see when I press the dot you can have the properties related with the this object class. So we'll have the name. Okay, so when I run this, you can see Ravindra is printed. That means what you have to remember here, how to define the structure with the struct keyword, how to pass the properties how to declare the properties inside the structure, how to create the instance of the structure, how to call this person structure inside the for the instance, and then we are printing how to call the that object properties. Okay, so similarly I can create suppose that one more instance here, let person1, and similarly I can again, okay, similarly I can have the second name here like Mangala, and when I call this now here, if I want to print this, I will go to the person1. Sorry, here I have the person1 will be there. So I will go here, person1 dot name. Then if you run this, you will get the Mangala. So such a kind of thing. You can also add the new property here. Suppose that I have added one more property here, where suppose that age return type is a integer. Sorry, with the data type as a integer, int. Now you can see, so if I want again to print the age, then person dot, you can see, one second, you have to call this let person, one second, I will call this like this. We'll change this here. So when I call the now person, we'll have this two things, string and int. So string I will put here as a Ravindra, and age I will put 23. Okay, so for the some time I will comment out this. Okay, now when I run this, you can see Ravindra is printed because we have printing only thing. If I print the age here, you will get the person dot. Now in previous case, when I am having only one property, this guide is showing only that property. Now I have added the age property that is also shown here. So I will call the age here. And now when I run this, you can see the age is printed. So like this, you can create the structure, you can add the property there, and you can call that particular property. Now we are moving further, adding the functionality similar to the how we are able to add the properties to the structure. Similarly, you can add the methods to the structure. So here we have added one method called as a say hello to the person struct. Okay, so similarly you can also call that function or the method by person dot say hello. Okay, so I will also create this function. I will create this function here. So here now so person, you can put here Ravindra 23. So that I will call here print, or suppose that I will call here your method, like person print person dot say hello. So we'll calling here the method, and when if you run this, you can say hello there, my name is Ravindra. Okay, so this will be printed like this. No need for the print here, you can directly go like this, print to say hello. So no need for like here, we can directly go like this. Okay, fine, super cool. So that means similar to the you can create the structure, and then we can add the properties and the function or the method to the structure. Then instances, how to create the instances of the structure. Now here we are having the structure shirt, having the two properties, size property and the color property. And for the two, we have created a two instances of this shirt struct, that is my shirt and your shirt. So this my shirt and your shirt are called as the instances of the struct shirt. Similarly, we have one more struct named as a car, having the three properties: make, year, and color, with the as a the data type as a string, integer, and string respectively. Then four functions: start engine, drive, map, park, and steer. These are the four methods which I have declared inside the struct car. Then two instances we have created, first card and second card. And when we call this first card and second card, values we have provided for the make, year, and color. And also we have called the methods start engine and the drive here. So this is the regarding we can create the how to create the instances of the particular struct. Okay, so if you run this on the playground, you will see I will clear this. So here we require some, okay, so for some time we will comment out these functions. We have not written anything there. We'll comment out this. This will also. And then if you run this, Okay, so here you can see after running, you will have the car object is created here. So if you print it here, we print the first card here, first car. If you print here, you will see make Honda year 2010 and color is printed. Okay, so that means we have created the two instances, first car and the second car of the car structure. Then the next part is the initializers. Initializers are again important part in case of structures. Now we know that all the structures come with at least one initializer. This initializer is similar to the function that returns a new instance of the type. Many common types have a default initializer with no arguments. Now, when we create the instances, whatever the instances created from the initializer have a default value. Here we are going to use the init as an initializer. The default for the string is double quote. Default for integer is 0 and default for bool is a false. You can see on this slide for the default value initializers for the string is double inverted commas. Then default for the integer is 0 and the default value for the bool is false. Now for the initializers default, you can see here we have created here. This is an example. You can see we have created the structure odometer here and we have provided the default value to the property count, that is 0. So whenever we are going to call this property odometer.count, you will get the 0 on the console output. Now the next important concept of the initializers is member-wise initializers. So when you define a new structure and don't declare your own initializers, in that case, the Swift creates the special initializers. That initializers are called as a member-wise initializers. So when you create the structure and you have not declared any initializer, in that case, Swift is having the Swift is creating the special initializers that are called as a member-wise initializers that allow you to set the initial values for each property of the new instance. So here you can have the odometer constant, let odometer equal to odometer count 27,000, print then odometer dot count. So for this we'll get the console output as a 27,000. So the member wise initializers are correct approach when there is not a default state for the new instance of your type. So here we have created one structure called as a person with the name property. Now if you want to call the member wise initializer, you can use the type name followed by the parenthesis containing the parameters that match each property. So here we have one created method say hello. So print hello there. So when we pass the name here, when we created the instance person and when we pass the name, so that is the member wise initializer for the this structure. Similar for the car also, we can have, sorry, shirt also, shirt and car also. When we have created the instant my shirt and the shirt size XL color blue will be the member wise initializer. Similar for the car, first car will be the let first car equal to car, make Honda, year 2010, color blue is the member wise initializer. Then the next topic is the custom initializers. So you can customize the initialization process by defining your own initializers. The custom initializers have the same requirement as the default and member wise initializers. Here, all the properties must be set to initial values before completing the initialization. So here you can consider the temperature structure with the Celsius property. If you have access to the temperature in the Celsius, you could initialize it using the member wise initializer like this. But this is the member wise initializer you can have. But if you have access to the temperature in Fahrenheit, then you would need to convert that value from the Celsius to the Celsius before using the member wise initializer. So for that, what we can do, first you can have the Fahrenheit value, then you can convert that value Fahrenheit to the Celsius by formula Fahrenheit value minus 32 divided by 1.8, and then you can use that, initialize that. Each instance, you can see each instance of the temperature is created using the different initializer and the different value, but each ends as a temperature object with the required Celsius property. Okay, so you can have here. Okay, then the next topic for the structures is the instance methods. Now, instance methods are the functions that are called on the specific instances of the type. They provide the ways to access and modify the properties of the structure, and they add functionality that relates to the instance purpose. So here we have created a size struct with the instance method area. You can see that calculates the area of the specific instance by multiplying the width and height. So you can have the struct size here with the method instance method as a area. You can call this by creating the instance sum size equal to size, and when you call the area equal to sum size dot area is assigned to the value. You can assign that to the particular value. Now here the sum size instance is of the size type, and width and height are its properties. The area is an instance method that can be called on all instances of the size type. So here, this is the thing. Sometime instance is of size type and width and height are its properties, and the area is an instance method that can be called on all instances of the size types. That means you can, some size is the instance of size, so that so area can be called on the all instances of the size type. So this is called as the instance method. Then we will have the mutating methods. Occasionally you will want to update the property values of the structures within an instance method. To do so, you will need to add the mutating keyword before the function. Now here we have took one example, that is struct odometer var count default value is 0. In this example, a simple structure stores the mileage data about the specific car. So here what we are doing, storing the mileage count to be displayed on the odometer. Increment, we have to increment the mileage count to the update the mileage when the car drives, and we have to potentially reset the mileage count if the car drives beyond the number of miles that can be displayed on the odometer. So for the increment, you can use the mutating keyword. How? So here you can see mutating function increment count plus equal to 1. Similarly, mutating function increment by amount int count plus equal to amount. And when we want to reset that, also mutating function reset count equal to 0. That means when we want to update the property values of structure within an instance method, you can use the mutating keyword. So instance method is here. Property values can be updated here, and you can call it by where odometer dot increment by 15, odometer dot reset, etc. So if you want to run this, we'll go to the playground. So when we call this, you can see odometer count defaults to the 0 here. Then odometer dot increment is incremented to 1, incremented by 15. If you print this, suppose that if I print this, print, print this, you can see so if I print this, okay, so you can use these mutating methods for the structures. Okay, so instance method. Then the next topic is a computed properties. Now computed properties are the Swift is having this feature of computed properties that allows a property to perform logic that returns a calculated value. So here if you consider this temperature example, you know that the most of the countries in the world use the Celsius scale of the measurement for the temperature. But in some places like in US, you will use the Fahrenheit, and certain will use the Kelvin. So it might be useful for the temperature structure to support all the three measurement system. So we have created a structure with all the three measurement, that's Celsius, Fahrenheit, and Kelvin. If you use the member wise initialize to this structure, okay, anytime you would write code to initialize the temperature object, you would need to calculate each temperature and pass all those values as a parameters like this. You can see this on the slide. An alternative would be to add the multiple initializer that hand the calculation. So we will try this by using adding the multiple initializers like this. Here we have added the multiple initializers for the Celsius, then for the Fahrenheit, and then for the Kelvin. So you can use this computed property. Now here you can have, you declare the property as a variable. You must also explicitly declare the type. So here you can have let current temperature equal to temperature Celsius 00 and print current temperature dot Fahrenheit. So this is means current temperature equal to temperature Celsius. Okay, what we have created here, computed property struct Celsius and Fahrenheit, Celsius, Fahrenheit, double Celsius into 1.8 in plus 32. So we have created an instance of that current temperature equal to temperature Celsius 00. If you print the current temperature dot Fahrenheit, it will give you the value into the Fahrenheit. This is called as a computed properties. Similarly, you can add the support for the Kelvin. You can do it yourself. Okay, similarly, you can add the Kelvin here. Then the next part is the property observers. Swift allows you to observe any property and respond to the changes in the property's values. These property observers are called every time a property's value is set, even if the new value is same as the property's current value. There are two observer closures or blocks of code that can define on any given property, will set and did set. So here we are having one example, having the step counter which has been defined with the total steps property. Both the will set and the did set observers have been defined. Whenever total steps is modified, will set will be called first, and you will have the access to the new values that will be set to the property value in a constant name as a new value. After the properties value has been updated, did set will be called, and you can access the previous property value using the old value. So this is the use of will set and did set. So when we try to modify this, okay, suppose we will run this onto the playground. And when we try to run this properties like if you call this, and when you run this, you can see about to set total steps to 40, added 40 steps, then this can be Okay, fine. Then about to say to steps to 100 and then added 60 steps. Okay, so that means here you can use this concept of property observers. So here we will come to the end of the structures. I will give you the exercise laboratory session for the structures. The link for the lab for the structures playground will be provided inside the description. Please like and subscribe. Thank you.